when we did the worksheet in class, did you upload it? I don't know. Let me see. Oh, the one about percentages, Dantana, the one we're going to finish up. Let me see. Oh, man, that would have been smart, wouldn't it? I don't think so, but I can put it up there right now. I don't know what help that's going to be, but oh well. Let me put it up there right now while I'm thinking about it. So I'm going to post the, I think did I do it in my, no, I didn't. All right. Percentage hypothesis test worksheet. Crap. Let me see. Man, I don't know if I can do this on the fly like this. Let me see. Come on, where are you? All right, I need to do this first. Fine. Canvas sucks. All right, sorry, did I say that out loud? All right. Where are you? Oh my God. All right. Sorry guys, I'm trying to post this. Somebody had a really good point. It would have been really nice if I would have posted that worksheet we're working on. That would have been really smart. So I'm just trying to do it right now. Okay. Do. Bam. Bam. Oh man. Everything's so simple. It's like only 18 steps or something. Okay. Yeah. Okay. All right. So if you're just joining, I'm so happy I got all that recorded. If you're just joining us, I just uploaded the worksheet that we're working on. We're going to finish up today. The one about percentages, the hypothesis test percentage thing. Okay. So anybody have any questions from homework? I had some questions earlier. My office hours. Anybody questions? No questions? Questions? Okay. We're going to jump right in. If nobody has any questions, we're going to jump right back in. Now, of course, I mean, I would think there might be some questions because what's happening today? We have the quiz. We have a quiz today because we're all crazy, right? We have the quiz. It's going to be on hypothesis tests for means. No percentage hypothesis tests on today's quiz because we just got into that last time. Okay. So let me see. Let me share my screen. So you should see. Let me see. Maybe pull up my. All right. You guys remember this? You guys see this? The passing a 4-week stats class problem that we started last time. Do you guys see that? Anybody?
Yes.
Yes. Okay. Thank you.
Yes, we see that.
Thank you. So we got this far. So let's kind of recap what we did, right? So if you read through this, we can see that the claim is right here. Test the claim. You got to love it when I'm that nice. Test the claim that the proportion of students is the same. So that was nice. That was almost too nice to believe, right? So P was, our claim is that P is 0.845. The population percentage of students who think this is true is the same as 0.845, same as the instructors. Okay. And of course, that went into HO because it has an equal sign. And then H1 is not equal to, and that's why it was a two-tailed test. Let me know when you have a question. I'm just kind of catching us up with what we did last time. Checking to see if it's normal enough. What do I do if it's a means problem? What do I check if it's a problem about means? How do I check to see if it's normal enough? If it's a hypothesis test about means? Chicken, lettuce, tomato. If you have no idea what I'm talking about, it's okay. It's just what I call it. Anybody? Yes, Monica, yes. If it was about means, n greater than 30. This problem is about percentages. So Monica, you're right. If it's a means problem, n greater than 30. This is not a problem about means. So of course here, I have to check, like Livia said, I've got to check NP and NQ, which is what we did. It should sort of make sense. If there's percentages involved, then the test has to involve those percentages somehow. So we got both of those to be, I'm kind of pointing at my monitor where the thing is. I have no idea why I'm doing that. They both turn out to be greater than or equal to 5, right? So that was good. That means it's normally enough. I could do something. I could use z-scores. I don't know. I think I made a big deal out of the fact that, let's see if I can, let's see. You guys know, I always want to point this out for you. I'm going to stop sharing for a second. Hey, everybody. Let me turn off Toby. There's Toby. Bye, Toby. Man, I have no idea. I really hope you guys get what I mean when I say this, because I've said this kind of thing a few times. You're not allowed to have notes on the formula sheet, but formulas are notes. Remember? Formulas are notes. So remember this. This is so kick-ass cool because it reminds you when you have to use T, right? Do you guys also notice how many formulas are there for percentage confidence intervals? And I know somebody out there right now is going, confidence interval, talking about hypothesis test, Jeff. The point here is there's two formulas for means, right? I might sometimes have to use z-score for means, and I might sometimes have to use t-score for means. So same thing happens in hypothesis tests. You have to use z-scores or t-scores for a mean problem, depending on which standard deviation you know. Look at the percentage. How many formulas are there? 1. Is there any formula with percentage with a t-score? No, because t-scores were invented for means problems. You only ever use z-scores for percentage problems. So either it passes the test and you use z-scores, or it doesn't pass the test and you don't do anything. Okay, all right, coming back. So again, those formulas, it's crazy. They're trying to help you. They are, and I think we're just so not used to trusting what formulas are trying to say. All right, I have no idea if you guys are still with me or ever were. Were you ever with me? I'll get over it. All right, so coming down here. So now, let's finish up this step here. How the hell do we get 1.645? So we knew that alpha's 0.10, two-tail test, z-score. Two-tail test, alpha's 0.10. Go all the way to the bottom for the z-score. Where am I at? 1.645. All right. Hopefully nobody is freaked out at all anymore that we use the t-score chart to get a z-score sometimes. If you stop, you get a t-score. If you go all the way to the bottom, you get a z-score. Kick ass. Okay. I'm in a very strange mood so far today. We'll see what happens. So that's where we got the 1.645. So there is my rejection region right in there. Don't you dare move. Let me shade it. Okay. So how do I say that? Take a second and try to write the words for that. If Z star is what, then we do what? Don't say it, don't type it, just write it. And then I'll catch up to you. All right, so let's see. If Z star is less than negative 1.645 or greater than 1.645, what can we do then? If either one of those is true, what can we do? Anybody? If either one of those is true, what can we do then? Thank you. So, all right. I know this kind of problem is the perfect problem for students to get really lost in. I understand that. There's 5 steps. Holy shit. But the idea, you can get really lost in the details. And you're all like, yeah. The null is the guy who thinks it's in here. I keep saying that. Do you guys understand that? Because the null is the one that has an equal sign. So it thinks it's in here somewhere. So if I get here or there, looks like that null dude is wrong. I got so far away from where he thought it should be, it looks like he's probably wrong. I can reject what he said. So if my Z star gets into the rejection region, and this is the reason we call it rejection region, I can reject the null, become a word, which means I can support the high. I just said the same thing twice. Ugh. Oh man. Cold, having a cold in the time of COVID. Okay, is everybody semi-decent with that? You guys all right? Anybody not okay with that? All right. You guys are all like, just let this class end. All right, it's almost there. We're less than a month away, guys. All right, so do part D. Go ahead and do part D. Let's see. Can you, so write down what N is, what X is, figure out what P hat is. I'll put that up there for you. Just take a minute and figure out what P hat is from the information. And please, dear God, I can't see your faces anymore. And I used to be able to read something in everybody's eyes a bit as to how much or how little they were getting something. Please speak up if you got a question, if you're not sure what the hell's going on. Does anybody figure out what P hat is yet? Wait a minute, I got that backwards. No, I forget. Is it 282? Yeah, 282. Okay, nobody's helping me out today. Shit. Is anybody out there? So how do you make a percentage? It's the part divided by the whole. So if I talk to 70 people and 3 of them say yes, then that's 3 out of 70, 3 divided by 70. So here it's 282 out of 322. That sounds reasonable. Anybody else get that same thing? Hopefully so, because it's right. So please, dear God, if you don't see how we got that, let me know. So it's just 282 out of 322. Bam. And now I got everything I need. Believe it or not. Do you notice how I do not calculate Q hat? I don't care what Q hat is. I don't. Why? Because I already know what P and Q are. We already knew from up here. Remember this? So P is 0.845, so Q must be 0.155. Is everybody cool with that? P and Q have to make 1 always. So I know what P and Q are. So let's see, Z star equals, get over there. My data, it's always my data first, 0.876, minus the supposed middle, which is 0.845. Right? How different are those two things? Divided by, where am I at? Square root of 0.845 times 0.155 divided by n, which is 322. Okay, let me stop. Does everybody see where all the parts of that came from? Anybody not see that? Please tell me now. This is the learning phase of things. You don't want to have a question during the testing phase of things, because then I can't answer it. I had a student one time get really upset at me because I wouldn't answer a question for it on the test. I was like, wrong expectation. Okay, so let me try to do this in the calculator and show you. If anybody gets an answer, let me know, and then we'll compare. 155, okay. I have an answer. Do you have an answer? Are you trying to find an answer? There's a possible answer right there. I don't know. I don't know. Could be true. Anybody else have a different answer? Or you get the same answer. I guess I can just sit here for like 10 minutes just doing this. I got, oh, there's another person, Rudy. Rudy's out there. Rudy's like, just keep going, dude. Good Lord. Okay, so yeah. So I got 1.537, otherwise known as 1.54, right? We're still going to do z-scores to 2 places, because then I can look up the p-value. Now, take a second. Take a few seconds. Find out what the p-value is. This is a little bit evil. Let me see if you guys remember what a p-value is, what to be careful about, because it's a two-tailed test. And if you don't know what a p-value is, you could say, hey, Jeff, what's a p-value again? And then I would tell you. Sorry. It's a combination of loopiness, and I cannot see you people, so I don't know if things are going okay or not. I have no idea. Tired, loopy people in quarantine. All right, so somebody help me out. P-value. Oh, crappity doodah. Oh, well, that's close enough. P-value, what does it mean? Anybody remember I told you 2 ways to interpret it? What's it directly, physically mean? How did somebody find it? Has anybody found it yet? Can anybody answer any of those? What is the p-value? What does the p-value mean? Is this how it's going to be now? Oh, I got an answer. All right, that sounds way too big. And look at that. All right, so let me draw this on the chart. Here's Z star, right? Z star is right here, roughly. Make a line. No, I don't do that shit. Get out of here. Let's try this again. Make a line. Okay. What happened? Oh, I love my computer so much. You will make a line there. Okay. You will make, okay, screw it. That's fine. That's fine. That's fine. I'll stop. I'll stop. Okay. My computer's going to like strangle me during my sleep. I'm not sure why it says divided by 2. Again, it's not 9382. Come on, we're better than this, guys. The Z star, the p-value is the area in the tail that my Z star makes. So when you look up 1.54, you're going to get the area below that red line. You want the area above it, and then there's one more thing you have to do because it's a two-tailed test. So what is the area above 1.54? Do you guys see what I'm saying? So let me see. First off, let me double check. I'm pretty sure the 9382 is the right first step. 154, 9382. I love it. That's the right first step. Is that the area in the tail of 1.54? No. Right? That's the area that's down here, of course. I want the area, I need the area that's in the tail up here. No, one that. One that? What's happening?
I meant that it was 1 minus that thing.
Oh, I see.
Yeah, 1 minus that.
I was like, oh my gosh, what is one fat? All right. Yes, so the area in the tail of 1.54 is going to be 1 minus the 0.9382. I love it. So that's 1 minus, oh my God, every day my computer gets a little bit slower. 0.9, what was it? 382. And that is 0.06, I think I saw this earlier, 618. Yeah, there we go. But Livia, you got the wrong symbol there. Since it's a two-tailed test, you have to double that. So the p-value is 2 times 0.0618. Otherwise known as 0.1236. Okay, let me stop for a minute. Please let that make a little bit of sense. I desperately, now watch, you gotta see this, you gotta see this. On this picture right here, there's a really easy way you can answer this question. Where is alpha? On the picture we made in part C, where is alpha? And yes, I am aware that that looks like the Fisher-Price picture of statistics, but yeah, it's the rejection region. In fact, a really nice way to say it, it's the green area, right? It's the green area. That's the alpha, right? And that's the area that goes with 1.645. So 1.645 is what the book calls the critical z-score, if you've seen that in the book at all. So it's the rejection region z-score, and alpha is its area. My z-star, its tail area is the p-value. So it's a beautiful analogy. There's the rejection region and alpha. And then there's my z-star and p-value. They're the same things. They're the same things. So the p-value will always be the area in the tail or tails that my z-star makes. So for a two-tailed test, you just double it, just to be fair. Woo! Maybe. I mean, okay. So normally, it's really, really, really unlikely that the p-value is bigger than 50%. Like crazy unlikely. The only kind of problem that would happen is a problem you should never even do. The only way that could happen is if I claim that something is more than 20 and my sample is 10. Should I do any work if my claim is it's more than 20 and my sample comes out to be 10? I really want you guys to think for a second. Come on. Does that at all back up my claim? If I said I think the mean is more than 20 and my sample mean was 10, is that ever going to be evidence that it's greater than 20? And I don't know. You guys are like looking at your laptop right now going, I don't know what you're saying, funky ass dude with a beard nowadays. Just think about it for a second. No, not just probably not, definitely not. If you're like, man, I think the average age of the people next door is 50, right? And then we take a sample and the average age I get is 10. That doesn't prove that you're wrong. It's just definitely not evidence you're right. I would never even do the 5 steps. Holy shit. I'm like, whoa. I thought I was this and my sample was on the wrong side. I'm not going to do it. So as long as we're not doing problems like that, then the p-value will always be less than 50%. Okay, I'm just trying to help you guys identify when the answer is obviously wrong. All right, maybe. It's all about the tails, right? It's all about the tails,
Professor, I have a question.
Yes.
So, you said when you're doing a two-tail test, you have to multiply the area by ×2, right?
Yes.
And when you're doing a single tail test, you just leave it.
Yep.
Okay.
And you can think about it, multiply it by the number of tails.
Okay.
If you want to, because multiply by 1, it stays the same.
Mm-hmm. And then you said that the rejection region is pretty much alpha, right?
The area in the rejection region is alpha.
Okay, area.
That's how we figure it out. That's how we look up the z-scores to see what area, what z-score goes with that area, right? That's why they're connected.
Okay, thank you.
Sure. Okay. So even before we did the p-value, just look at that p-value real quick. And just to remind you guys, the p-value is the probability that the sample, that the mean is true given that the sample we got ended up where it did, right? Is that a small probability? No, not really. 12% is not small, like less than 5% normally is small. In fact, in this case, the alpha tells you it sets up what unusual 10%. 10%. And we got 12%. That's not good enough evidence. I don't have to look at it that way though. The 1.54, did we make it in the rejection region? No. So either way you look at it, it's not enough evidence. We didn't make it in there. So how do I word the conclusion? In fact, let me say this right here. What's the little mini conclusion I can write right here? We didn't make it. So what does that mean? What do I type here? What do we end up, what's the answer before I make it in big paragraph form? Do we reject a null? What do we do? Did we make it? We did not succeed, did we? So therefore we did what? We desperately, horribly, completely, epic, you're just not gonna play. All right, we failed. We failed. Thank you, somebody at the last second. Failed to reject the null, which means we failed to support the high. So when I go to write my conclusion, and this is normally the last thing people have a big problem with, when I go to write the conclusion, what language do I use? Well, what was my claim? Which thing was my claim, the HO or the H1? You can see what the claim is, and you can see where we put it. So what was the claim? HO. Does everybody see that? I always get somebody confused. I see what the claim was, and I can see where I put it, so I know which one is the claim. So what language do I want to use? This language. The claim was the null, so I want to use that language. We failed. We have not found sufficient evidence. So when you blow these words up, fail becomes we have not found sufficient evidence. Oh man, I was about to say something about, wow, I typed all those without misspelling anything. We have not found sufficient evidence to reject the claim. Please see that. Everybody's like, how do I know when to say reject or support? It's which one's the claim? Use that language. Again, the problem is trying to help you. We have not found sufficient evidence to reject the claim that plagiarize. Let me see where I'm at. The proportion of students is the same as 84.5%. Now, since our claim was, oh boy, the portion of students, oh, you gonna let me in there? There we go. Oh, you gonna let me in there? Sorry, guys. Sorry, I just can't let it go. There. All right, freaky ass morning, I tell you. So, our claim was that it was the same. Are we happy about this conclusion? We failed, didn't we? We failed at the test. If our claim was the null, did we want to reject it? If that was our claim, the null, did we want to reject it? Did we want the thing to tell me I was wrong? I love you guys so much. So it's not a huge deal what I'm trying to tell you right now, but our claim was the null. We went into this kind of hoping that it didn't get discredited. And sure enough, we didn't find evidence to say it was wrong. If we did find evidence to say it was wrong, we'd be cool with that because we're scientists. And we're not married to our ideas. We want to know the truth. So we'll let go of shit quick, right? Disprove evolution. We'll be all, holy shit, let's look at what's really going on. Damn, you got to do it first. I'm sorry, I have no idea where that rant came from. I watch too many flat earth videos and I get concerned about our future. Yes, there are people that believe the earth is flat. If any one of you are that person, do not say a damn word to me about that shit. I don't want to know about it. Okay, so let's do this. Any questions on that? We finished that problem up. It's done. Any questions on that problem? All right. So let's do this. Let's see what's the best way to do this. Let me stop sharing. All right. I'm going to write a problem down for you guys. And you're going to do it. Boop. All right. We feel that more than 10% of people like staying inside all the damn time, right? This is like the ultimate introvert time right now. It's like, yes. We feel that more than 10% of people like staying inside, right? We sample 100, well, let's say 430 people and find, what you got, Jeff? Let's say 49 of them say yes. They like to stay inside. All right. So I'm going to let you try to just do the first step. Write down the hypotheses. What's the claim? And write down the hypotheses. Just do that step. I got too much crap up here. Oh, Jesus. Oh, Chiman. All right. Okay. Stay back. All right, what's the claim? Yeah, more than 10%. So we claim that the percentage of the population of people that like to stay inside is more than 10%. So of course, which one is that going to go in for? The high, 11. Why? Because there's no equal sign. So what goes in for the null? What's the opposite of greater?
Less than or equal?
Yes. Less than or equal to 0.1. You keep this consistent. All right. You know, I did get some more whiteboard decal. I just got to put it up here. I need more space. Now, continuing. Let me push myself way over here. So that's step one, right? Step two, can you, if alpha is 0.01, right? Alpha is 0.01. I'm sorry. That's step three. I'm getting ahead of myself. Step two, of course, is do we use Z or nothing? What do I have to check here?
If the distribution is normal,
Okay, and how do I check that?
is that NP and NQ? Yeah.
Yes. So NP, what's N? $430. Oh, I gotta watch my. So 430. And what's P? Point one. Kick ass. And that's 43. Multiplied by 0.1 is so much fun. 430 times 0.9, of course, is going to be 387. Is that right? I'll never know. I'm going to say yes. And those are both what? What's important about these? They are both what? What tells me it's normal enough? The fact that they are both. What do I check? Yes, they're both at least 5. Check! I can use z-scores. So that, again, it replaces n greater than 30. Right? Replaces n greater than 30. So do the rejection region. Draw the rejection region if alpha is 0.01. I'll wait. If you're having trouble with any of these steps, let me see how I can say this correctly. That's a bad sign. That is a bad sign. But you just ask for help, right? The steps are fundamentally the same for percentages and for means. They really are the same. There's just a couple things. The check is different and the Z-star formula is different, right? Because of course I got to figure out the right standard deviation. I don't think I said this earlier. How many tail tests is this? Oh, okay. I see that. One tail test. Alpha's 0.01. Where's the tail? Right or left? Yeah, because P is greater than 0.10. That points you in the direction of the tail. So look up one tail, 0.01, get the z-score. Yes. So if z star is bigger than 2.326, we reject the null and support the high. My gosh. Whew. Okay, maybe. So we set up where evidence starts. HO thinks it's in here somewhere. So if our sample gets out there somewhere, we can reject the null. That just makes sense. Somehow in the middle of all these details, it makes sense. All right, so let me get rid of some of this non-important stuff here so I got some more room. We need to know 49 and 430. So let me rewrite that up here. Whoop. That is 430. X is 49. We can figure out what p hat is. All right, so do that step and then figure out what z star is. I'll put the formula up here. I'll wait. Do. Oops. Who's got p hat? Anybody? I don't even know where my calculator is. 0.114? Let's see. 0.114, yes! P hat is 0.114, right? It's just 49 divided by 430. And of course, I left myself no room. Good job, Jeff. So then z star equals my data, 0.114, minus the supposed p, 0.10, divided by the square root of PQ over N. Woohoo! Bum, 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 bum. You're going to try to do that in your head, Jeff? Sure, it sounds like fun. 20. What was that? 0.03. 0.028. 0.03. Is it coming out to be? Come on, Jeff. It's like 1.07. 0.97? All right, I'll deal with that. It's not too bad. Is it? I didn't do it. I tried to do it in my head. Why do I do that to myself? Yeah, 0.97. Thank you. I like it. I like it. So let's put that in our picture. So that's how far our sample got. So it only got this far. So can I reject the null, or do I fail to reject the null? Which one? Yeah. So we didn't make it into the rejection region, so therefore we fail. Our sample got less than one step, less than one standard deviation away from the 0.10 claim. That could happen. A sample could randomly show up above or below something. It's not enough evidence that the real percentage is more than 10%. So the sample percentage is definitely more than 10%, right? It's 11.4%, but that's just a sample. It didn't get far enough away. I expect a sample to be different, and this was not different enough to be evidence. It's only 0.97. It's nowhere near the evidence it needed to be. So we fail to reject the null. Fail to support the high. All right, so let's try to write this conclusion. Got it. Which language am I going to use? Which one was my, of course I just erased them, but what was my claim? Which one was my claim, the HO or the H1? Hopefully you've kept good notes. Which one was our claim, the HO or the H1? Which one? High. Oh yeah, so the high was the claim. So I'm going to use this language, fail to support the high. Screw that language. Get out of here. I got to use the language that talks about my claim. That's my answer's got to be about what the claim, what happened with the claim. Fail. We have not found sufficient evidence to support the claim that more than 10% like staying inside. Okay. All right.
Professor, so
Yes.
when you're setting up your picture, your rejection zone and all of that, so I'm just having trouble understanding where you're getting the z-score from. So
Which
you said
z-score?
alpha was 0.01, right?
0.01.
Yeah, and then so where 26 from?
0.01 alpha, and equally importantly, one tail, right?
Yeah, so you did it from the T table? Okay.
Yeah, because that's, I don't have to. I do not have to get it from the T table.
Okay.
I don't. I could get it from the Z chart. I could. In fact, let's do that instead.
Okay.
If there's 1% right there,
Mhm.
what's down here?
Oh, okay, I see. Yeah.
And then you could use the Z chart. But why would I do that shit to myself?
Yeah.
The T chart is so beautifully set up for hypothesis test, right? The 1 and 2 tail. I just have to remind myself that Z-scores live at the bottom of T-score chart. So it actually is a Z and T-score chart. It's kind of nice.
Okay. Thank you.
You're welcome. Okay. Anything else about that? If you look at the whole problem all at once, you'll go a little insane. It's 5 parts. Make sure each part makes sense. And at least 2 of the parts are old news. Oh, we got like 10 minutes left. Not too bad. I was kind of expecting more questions, so I didn't really prepare more than that. Hopefully you guys don't have questions because you understand it all, I guess I'm going to find out later. Okay. If you don't have any questions, that's all I got. Anybody have any questions or? Let me see, I'm still blocking this image. Okay. Wow. All right. How we know if it's one? Okay. So of course I've erased the stuff, but let me see. Can I make some room up here? Has everybody got the Z star stuff up here? Yell at me now if you don't want me to erase this. Okay. So if her claim was P is at most 11%, right? If that was her claim, where would it go? Which one would it go in for? HO or H1? Yes, because it has an equals. So then what's H1? And Rudy, I'm answering your question, by the way. Yeah, what's H1 then? Somebody's trying to say something maybe? What's H1? Anybody? What's happening out there?
Less than 0.11.
Yes. So remember, H1 is the one that we can show evidence for. H1 is the one that sets up the rejection region. How can something be less than 0.11? Where would it have to be on the chart, on the picture? Where would the sample have to be to show evidence for this? Where's the, right, less than, right? Less than, so it'd have to be there. That's the only place evidence could show up for the H1 statement. Do you guys see that? So anytime H1 is less than or greater than, that's one tail. The only time it's going to be two tails is if H1 is not equal to, because how can you be not equal to something? You can be more or less. Then it could be either side. That's the only time it's going to be a two-tail test. So it really is just where would evidence have to show up to support this? It'd have to show up down here, less than. If it was greater, then it'd have to show up there. If it was not equal to, it could show up either side and be evidence that it's not equal to, right? Yes, Monica, we do. I said that earlier. I reminded you guys, quiz today, it's just on hypothesis test for means, not percentages, but you know, everything we did is basically a review for that. I guess I'll put I didn't really put the formulas on there. I'll put them on there before I put them up. Anyway. There's not a ton of formulas for this. You guys all with me? So the quiz today is going to be on chapter 9, but only hypothesis testing. A quiz next week is going to be on, hypothesis testing for a mean. The quiz next week is going to be hypothesis test for percentages, and I'm going to put some type 1 and 2 error questions on there next week. Yay! Okay. I didn't say that. Yeah, if it's a problem about a mean, it could be Z or T, right? Yeah, those the Z and T charts, old news. It could be either one that you need. Don't forget, I put those charts up on Canvas. I think it's in the pages section, the Z and T charts, if you don't have one, or if you lose yours or something. All right, this makes me feel a little bit better. I got some interaction. Anything else, guys? You guys, anybody need to hang out for a bit? Ask any questions? You know, like questions are overrated, Jeff. Okay. Okay. All right. You're welcome. That's it, guys. I don't see any questions, so I'm gonna shut things down. And good luck on the quiz. Let me know if you have technical difficulties. Give me a few minutes to get it up there because I want to add the formulas on there. Okay. Don't freak out if it's not up there immediately. All right. Bye, everybody.